Multiplicative decomposition it is, or I guess, well, factoring is the technical term. So looking at some randomly generated natural numbers between 1 and 1000, like 343 and 806, we can go about factoring them by finding two natural numbers that multiply together to get back to that number. In the case of 343, we can do so with 49 and 7. And with 806, we can do so with 403 and 2. Mind you, I'm completely avoiding division here because I don't want to run into Q or the rationals without intentionally doing so. So we're just swerving away from Q for now. Eventually, maybe we'll get there somewhere down the line, depends on what you do. With that aside, in each case, notice that we can go even further. 49 can factor into 7 and 7, and 403, with some work, can factor into 13 and 31. But in each case, if we look at those numbers, we notice that we've hit a wall. The only way to factor 2, 7, 13, and 31 is by using 1, which isn't really an interesting number in our context. These numbers with uninteresting factors are called the prime numbers. They only have two distinct factors, 1 and themselves. Notice that this distinct qualifier stops us from declaring 1 as a prime number, as it only has one distinct factor. Now, at this point, you might also notice that there isn't any other way to factor 806 and 343 with primes. So, is this prime factorization unique? If so, can we prove it? And how can we find all the primes up to a given point? I'll leave it up to you to see what you decide to look into.